Today we're going to talk about points in 2-dimension. Normally at this level we only stick to 2-dimension. Later on, hopefully in Calc 2 or Calc 3, you'll see 3 dimensions, which is a generalization and what we're going to talk about today. Coordinate system. First, let's see how you show a point in 2-dimension. You can see that this is a rectangular coordinate system. This is normally called the x-axis, and we have the y-axis, the 2 direction. These 2 axes are orthogonal to each other. That means the angle between these 2 are 90 degrees. And how do you show a point in space? Normally it's use ordered pair. Ordered pair is in the form of, let me change this a bit to a smaller size. Okay, ordered pair. What does an ordered pair look like? Looks like an interval, but it's not an interval. It has 2 coordinates. The first coordinate is the x coordinate, second coordinate y coordinate, and there is a comma in between. This is supposed to be a comma. So if I want to show a point here, you can break down the x-axis and say these are 3, 4, 5. It's like the number line. Number line is in 1 dimension. If you have 2 dimensions, there are 2 directions. You can go left, right, up, and down. Okay, so let's say you're given a point 1 and 2. How do you show it? This means the x coordinate is 1, y coordinate is 2. So I'll find out what is x equal to 1. This is x equal to 1, y equal to 2. It's here. Draw a horizontal line across the y-axis, a vertical line across the x-axis. Their intersection is what you're looking for. So this point, maybe change it to color green. This point has the coordinate of 1 and 2. Similarly, if you want to find the point -3 and 0, -3 along the x, here is -3. 0 for y, 0 for y is still here. So the intersection of the 2 vertical and horizontal line would be this point. If you're staying on the x-axis, that means the y coordinate is 0. This is -3 and 0. That point. If you're staying along the y-axis, if you're on the y-axis, maybe this point. What is the coordinate of that point? 1, 2, 3, 4, 5 up. So y must be 5. What is the x coordinate? You haven't moved along the x. X is still at 0. This is the x coordinate. Is 0. And origin is simply the point when both x and y are 0, 0 and 0. So the origin is 0 and 0. And when you see 3-dimension, the origin in 3-dimension, you would have 3 coordinates, x, y, and z. So this coordinate system is nothing to be confused by. This is the positive direction. This is the negative direction as you deal with number lines. Going up is positive direction, negative is downward direction. So here, by the way, there are quadrants. By drawing these 2 x and y axes, you'll have first quadrant. Maybe I should use number. First quadrant, second quadrant. It's normally used when you deal with trigonometric functions, which we're not going to discuss at this point, but it's good to know. First, second, third, and fourth. Okay, let's use this. We're going to discuss the distance formula, but first we want to know how do you get to the distance formula? The distance formula is just to show the distance between 2 points. Between 2 points. It's nothing complicated, but these 2 points, you should know it already in 1 dimension. Let's say you have a number line. It's only 1 dimension. If I pick 2 numbers, something like 10 and 3, and ask you what is the distance between these 2 numbers, what is that length? You should simply say the distance is the difference between these 2. So 10 minus 3, which equals 7. So this length between 3 and 10 is simply 7. You can think about it as, what if the distance, what if instead of 3 this was something like 5 and negative 4? What would be this distance? It's still the same idea, 5 minus negative 4. It turns out to be positive 9. Because first you have to reach 0. 0 to 5 is 5. Then from 0 to negative 4 is another 4. So the total distance is still 9. So the distance between these 2 points in one dimension is just subtracting calculating the difference between those two values. What if we have the distance between 2 points in 2 dimensions? That means, sorry, let me fix this. Maybe draw a better line. What if I cannot draw a straight line. What if we have 2 points here in space, somewhere here, and there is another one? And you want to find out what is the distance between these two. So if I connect these two, there would be a line segment between these two. The question is, what is that length? And we want to figure out what is that length. So ideally, let me show you coordinates. Let's say you have 2 points. I'm going to use X and Y. This is X, this is Y. Again, that point has an X coordinate, and correspond to that, there's a Y coordinate somewhere here. But just to avoid XY, we say this is X1 and Y1, which means it's related to this point, which is your first point, X1, Y1. That's point number 1. Point number 2, you can show it as X2 and Y2. Those are just sub-indices to show that there is a difference between these two X and Y values. There could be the same X, the same Y, but just to show if there are 2 different points, you can do this. Okay, let's think about this. If I draw this straight line, sorry, let me use a different color just so you see the difference. If I draw this straight line from here to there, as well as this one, what have I created is a triangle. And the question is basically, what is the hypotenuse of this triangle? Because that would be the length, and which is the difference, the distance between the 2 points. Distance between x1, y1 to x2, y2. So we want to figure out what is the hypotenuse of this triangle. So I'm going to draw this triangle out here. What kind of triangle it is? It should be a right triangle, because you always find these to be orthogonal. The x and y points are orthogonal. So here, first we want to find out what is this length of the side and what is the length of the other side. If we knew that too, if I knew this is 3, this is 4, then Pythagorean identity will tell us what is the length of the hypotenuse. So I just need to figure out what is the length on each side. Okay, look at this length. What is that length? It is the difference between these 2 points. What are those 2 points? This is exactly x2. The other one is exactly x1. As we discussed it in one dimension, if you had 10 and 3, what would be the distance? It would be 10 minus 3. So the distance here would be x2 minus x1. The difference between the 2 endpoints. And the same distance on the other side, it would be the difference between the y's. y2 minus y1. Now I have the lengths on each side of the triangle. How do I find the hypotenuse? If you remember, if you have a right triangle, A, B, and C, Pythagorean identity is a squared plus b squared, this is from geometry, equals c squared. So what is c? C is your hypotenuse. C would be if you take a square root from both sides. This will cancel out and you would have square root of a squared plus b squared. This would be the hypotenuse. So here, our hypotenuse, which I'm going to call it d as the distance. The distance is square root of each side squared, a squared plus b squared. So each side squared would be x2 minus x1 squared plus y2 minus y1 squared. And this is what we call it the distance formula. Distance formula is just simply Pythagorean identity, but instead of drawing the triangle, you just given 2 points, you can figure it out. Let's try an example. Maybe by doing an example, it would be easier. Here, let me pick a green color. An example. Find the distance between the 2 points. Let's say 1 and 3. This is one of the points. The other point is 4 and 7. So you're given 2 points. You're going to figure out what is the distance between these 2 points. You can always draw it if you want a visualization. 1 and 3. This is 1 for x. 1, 2, 3. 3. That would be the point. 1, 3. And 4 and 7. This is 4. 1, 2, 3, 4. This would be 7. You want to find out what is this length. It doesn't really matter if the numbers are positive or negative. If it's negative, it would be from somewhere here connected with there. Okay, so let's try this example. You're given the formula already. You just need to find out distance by using that formula. So what is the distance? It doesn't matter which order you pick. You can say this is x1, that would be y1. This one would be x2, this would be y2. If you go with x1, y1, and x2, y2, it shouldn't make any difference. You should get the same result. The order does not matter. Just make sure that you're using corresponding x and y. I cannot say this is x1, that is y1. It doesn't make sense. If I call the first point to be x1 coordinate, the corresponding y should be y1. So the distance would be difference between x1 and x2. So 4 minus 1 squared plus difference between the y squared. 7 minus 3 squared. And if you simplify, 4 minus 1 squared is 3 squared plus 7 minus 3, 4 squared. Add them up, that's 25. Square root of that, simply 5. So this length is 5. We found the distance between the two numbers. And again, the numbers could be positive or negative. Doesn't really matter. You still follow the same formula. Let's try one more example just before we move on. So here, find the distance between these two. -1, -2, and 0 and 2, something like that. So what would be the distance? The question is, what is the distance? The distance would be difference in the x's minus difference in the y's. I'm going to call this x1, y1, x2, y2, just to show you that the order does not really matter. x2 minus x1 would be -1 minus 0 squared plus y2 minus y1, -2 minus 2 squared. And that would be square root of 1 squared plus -1 squared is still the same as 1 squared. -2 minus 2 is -4 squared. Do not write it like that because this means -4 squared, which is give you -16, but in reality you should have -4, the whole thing squared. This would be square root of 17. And that's the distance between these two. You cannot always simplify the radical, so that's okay. You can leave it as it is. Okay, we found the distance. How about midpoint? What is a midpoint? So if you have the same idea works again as you start from generalizing from 1 dimension to 2 dimensions. So let's assume that you have a number line. You have 2 points, 10 and 2. And I ask you, what is the point that is in the middle? This is what we're looking for. Midpoint basically means the point that it's between two other. Normally it's the midpoint of a segment, line segment. But in this case, let's assume you're given these 2 points, 10 and 2. They ask you, what is that number that is in between? I'm assuming you can guess. It should be in the same distance from both sides. This length and that length must be equal. That means the midpoint. You can guess that this is 6. And how do you find it? If you have 10 and 2, what would be the average? That's what you're doing. You're trying to find the average. So to find the average, always you add the numbers, divide by 2. 10 plus 2, 12 divided by 2, 6. So if the numbers were different, if they were negative or positive, does not really affect anything. This was 10 and minus 2. To find the middle point, I still add them together. 10 plus negative 2 divided by 2. You might look at this as a subtraction, but it's not subtraction. You're adding two numbers. It turns out that one of them is negative. The average would be 10 plus negative 2 is 8 divided by 2, 4. So this is 4. And if you look at the distance on each side, is 6. This is 6 and 6. So there, 4 is exactly in between. How about midpoint in 2 dimensions? No different. So if you have 2 points, let's say x1 and x2, again, y1, sorry. I'm going to stick with the same notation. x2 and y2. And they ask you, what is the midpoint of this? And so these 2 points, somewhere here is the x1, here is another x1 and x2. And they ask you, what is the midpoint? That means if you connect these two, you create a line segment. Between those two, there is a point. We want to figure out what is that point. How do you find it? Just simply take the average. How do you take the average? So the midpoint is the average. Average of what? I want to find the average of the x's, the average of this distance, as well as the average of that distance. This would be the intersection. So I need to find out the average of the x, average of the y. Average of the x would be add the x's together, divide by 2. Average of the y would be add the y's together, divide by 2. So it's no different than what you do in one dimension. Let's do an example. An example. Find the midpoint of a line segment connecting these 2 points. The 2 points are -1, 3, and 2, and sorry. Let me do maybe -5 and -7. How about that? Normally it's easier to pick positive numbers, but I want to show you that there is no difference in the formula. You stick with the same formula. So what is the midpoint? Add the x values together, divide by 2. So -1 plus -5 divided by 2, their average. And add the y values together, 3 plus -7 divided by 2. You're taking an average. You can calculate and simplify. -1 minus 5 would be -6 divided by 2, simply -3. 3 plus -7 is -4 divided by 2, -2. So this is the midpoint of those two. Is the number in between these two. It's a point between the other 2 points. If you draw these 2 points, they will be somewhere like here, -5 and -7, and -1 and 3 is somewhere here. Along the way, there's a point in between. That point is -3 and -2. This would be -3. That would be -2. Okay. Not complicated. It's just that you just make sure that you add the numbers correctly. You're taking an average in each direction. Okay, we want to discuss equation of a circle. Equation of a circle is a consequence of the distance formula. So let's first think about it in a sense of the definition of a circle. What is a circle? So if you have a point as a center of a circle, here, let me draw a circle. It's not even close to a circle what I drew. So here, Okay, they probably have I should have an option to create a circle. I don't really care about that. Let's say you have a point as a center, X and Y, A and B, whatever you want to call it. Call it X1 and Y1. If I pick another point in the circle, doesn't matter where that point is. Call it X2 and Y2. What do you know about that point? You know that distance from the point on the circle to the center is always a fixed number. That fixed number is what we call it the radius. Doesn't matter where that point is, it should always be this distance. It should be always r. From every point to the center, you should always have the same distance. So this is what we're going to focus on. What do we know? We know the distance between 2 points. How do you calculate the distance between 2 points? Distance between 2 points is x2 minus x1 squared plus y2 minus y1 squared. This is the distance between two numbers. And if we know the distance, meaning if you're given the distance as the radius, this means this d as the distance is already given, and we call it the radius. Then this would be the equation for a circle. Whatever numbers you put in here for x2 and y2, because x1 and y1 is basically your center, because the center is a fixed value. Sometimes they use a and b. So they say, instead of using this, if I ignore x2 and x1 and say this is true for every x and y, as long as x and y is on this circle, I can replace any number for x and y, then I should have r as the distance. So sometimes instead of writing it as x1, y1, they say let a and b be the center of a circle. And let r to be the radius. R is the radius. Then what is the formula? You don't want to have a formula for a circle in the form of radical. So if you square both sides, if I square both sides, I can cancel out the square and this square root. So I can say r squared equals x minus x1 squared. I'm going to erase this in a bit, but I just want to show you that this is the formula that I want to discuss. Y minus y1 squared. This is the equation of a circle, basically. Let me fix this. Minus y1 squared. Where did it come from? It came from the distance formula. But instead of x1 and y1, we want to say we already know the center. The center is given a and b. So instead of using x1 and y1 like the distance formula, we use a and b. By the way, x1 and y1, there is no problem if I say this is x1 and y1. That still is okay. But some textbooks use a and b. A is your x coordinate, b is your y coordinate for the center of a circle. So then the equation of the circle is basically x minus a squared plus y minus b squared equals r squared. And normally instead of having r on the left side, they write this r squared on the right side. They say equals r squared. So what is the equation of the circle? This is your equation of a circle. If a circle given with this radius a and b, and with the center a and b and the radius r, then the equation of the circle is x minus a squared plus y minus b squared equals the radius squared. Let me show you an example. Find the equation here. Find the equation of a circle with center, let's say 1 and 0, and the radius is given 2. So what is the equation? I'm going to use green to solve this solution. It would be x minus a and b is the center, a, b. X minus 1 squared plus y minus 0 squared equals radius, which is 2 squared. This would be your equation. Sometimes they simplify, they ignore the 0 because y minus 0 is basically y squared. That means any point that is on that circle, if you draw the circle, let's say here is 1 and 0, 1 and 0, and a circle with radius 2. Something like that. That means any point that is on this circle, whatever this point, wherever this point is, if it is here, here, doesn't really matter. All these points should satisfy this equation. By the way, this is 1. Okay. So, for example, this is easier to find this point right here. Since the radius of the circle is given 2, this point has coordinate 3 and 0. That means if you replace 3 and 0, it should satisfy the equation. You don't need to do that, but just to check to see if really this is ours. This is the correct equation. You replace 3 and 0. 3 minus 1 squared plus 0 minus 0 squared is it equal to 2 squared. 3 minus 1 is 2. 2 squared plus 0 squared equals to 2 squared, which is correct. That means that is correct. You can try another point somewhere here, because this one is easy to find as well. Is minus 1 and 0. You shift 2 units to the left, because the radius is given 2. You can go 2 up if you want. This point has coordinate. This is 2 up and 1 to the right, so 1 and 2. The same, you can do this. All those points, this is maybe a bit difficult to find out the other points, because they're going to be in decimal or radical form. But all these points should satisfy the equation. By the way, sometimes instead of writing 2 squared on the right side, instead of writing this 2 squared, why did I do that? Instead of writing 2 squared, write 4. And they ask you what is the radius. The radius would be simply take the square root, which is going to give you 2. So here, how about if the question was backward? What if I give you the equation and ask you find the center? Here is an example. Find the center and the radius of the given circle. Okay, so the circle is given as x minus 3 squared plus y plus 2 squared equals 7. Okay. If you compare to the equation of the circle, I'm going to write the equation of the circle on this side. It's good to do this always. Y minus a squared, x minus a squared x minus a squared plus y minus b squared equals radius squared. If you compare these two equations, what do you see is a and b. What are a and b? So I'm looking for a and b because it will give me the center of the circle. In this case, x minus a squared, x minus 3 squared. So I know simply x must be 3. Y minus b squared, y plus 2 squared. So what is b? B cannot be 2, because if it was 2, then you should have y minus 2 squared. But it is y plus 2 squared, so it is y minus 2 squared. It's the opposite. If you replace b with negative 2, then you have y minus 2, which becomes y plus 2. And so I have the center. This is the center. What is the radius? radius is not supposed to be 7. 7 is r squared. 7 is supposed to be r squared. So what is r? R is basically square root of 7 instead of having 7. So you take a square root from the other side. If it was 7 squared, then sure, radius is 7. But since it's only 7, the radius must be square root of 7. Okay. There is another type of questions that they often ask, and they say, given find the equation of a circle if they give you the center, and instead of radius, they give you a point on the circle. So let's do an example to see how you do this. Maybe before I do an example, show you what you can do. Okay, let's say this is the center of the circle and you have a circle. If I tell you this point A and B and tell you the radius, then you should be able to figure out what is the equation of the circle. But instead of the radius, if I do not give you this and give you a point here, let's say call it x and y. If I give you the point x and y and A and B, you should be able to find out what is this distance because of the distance formula. And after that, you have the radius. The distance between the 2 points is basically the radius. This is one way to figure out the equation. There's another way to do it, but I'm going to first try this one, then I will show you an example, show you another way as well. So here is an example. Find the equation of the circle. Equation of a circle with center. Let's say given center is given 2 and 1, and another point and a point on the circle, and point let's say point is 3 and 4. You can make up your own point, doesn't matter, on the circle. If the point is not on the circle, it's useless to us. If I give you this point and say it's not on the circle, it doesn't give you any information. So the point given and the center, it's going to give you the distance between those two, will give you the radius. So how do I find the radius? Radius is basically the distance between these two. If you remember the distance formula, it will be the difference in the x's squared, 3 minus 2 squared plus 4 minus 1 squared. You do this and say 3 minus 2 squared is 1, 4 minus 1 is 3, squared is 9. If you add them up, 1 plus 9, simply square root of 10. Do not forget the square root. So what is the equation of the circle? Here the equation of the circle is x minus the center, which is 2, squared, plus y minus b squared, which is 1 squared, equals to radius squared. Radius is square root of 10. The whole thing squared. So you can simplify it. Square root of 10 squared is simply square root of 10 squared is simply 10. Why did I? Let me erase this. Okay, sorry about these circles. They do not go away. So this is 10. There's no 0 here. And so square root of 10 squared simply becomes 10. This is one way to figure out the equation of the circle. Same question. Instead of using the distance formula, you can do this. You can say, okay, I know the general formula. So this is a second way to solve this equation. There's another second solution. You can say, I know the general form of the circle. I know it is x minus a squared, so x minus 2 squared plus y minus 1 squared. If I knew the r, then it would be r squared. But in this case, I do not know what is r. But what is given is another point. given point 3 and 4. So replace 3 and 4 into the equation. See what do you have. If I replace 3 and 4, I get 3 minus 2 squared plus 4 minus 1 squared equals r squared. Okay, 3 minus 2 is 1 squared, plus 4 minus 1 squared is 3 squared, and on the other side I have r squared. So what is r squared? I'll get that r squared equals 10. Do I need to figure out what is r? Not really. You can simply say, okay, r is equal to square root of 10. You don't necessarily need to find the radius unless they ask you. So what is my equation? Here is this equation. What did I just need to find? I just needed to find what is r squared. And I already found out what is r squared. R squared equals 10. So instead of this, I can say the equation is x minus 2 squared plus y minus 1 squared equals r squared, which is simply 10. As I said earlier, any point on the equation should satisfy, any point on the circle should satisfy the equation. So by replacing 3 and 4 into the equation, I'm just checking to see what is the r squared to satisfy this equation. And this is basically the equation of the circle. By the way, if they give you the diameter, you just need to divide by 2 to get the radius. So it's not very complicated. Instead of radius, if they're given the diameter, you should be able to still find the equation. Okay, I'm going to stop here, and next time maybe we'll discuss functions.